Hi. Okay, in this lesson 1.3 we're looking at rate of change. Rate of change is typically talks about what's changing, how quickly something's changing over time. So to introduce this section, we're going to look at the rate of change of a line on a coordinate axis. Now the rate of change, the slope actually is the measure of the rate of change when we look at a coordinate axis. The bigger the slope, the bigger the rate of change. So we can use the slope formula that we learned last year, which is slope is the change in the y, or the change in height, over the change in run. This is really rise over run. So when you think about this diagram here, and we look at the rise in going, say, from this point to this point, we can say that we've risen 4. We've also run by 4. So rise over run here would be 4 over 4, so the slope would just equal 1. But we can also look at, if we want to use this formula, what it's looking at is the y coordinates and the x coordinates of the first point and the second point. So here's the coordinates of the first point, here are the coordinates of the second point. We plug them in and we can get the slope that way. So if you look at another way, we'll look at the y2 minus y1. Here is the second point, so this will give us y2, and the y value is 4, the height is 4, minus the height of the first coordinate, and the height there is 0. Now for the x coordinates, the x coordinate of this is 4, the x coordinate of this is 0, and we plug it in, and I guess we get 4 over 4, which is 1. It's another way to look at it. So if you look at these, if you remember, if a slope is going up left to right, slope is positive. If it's going down from left to right, it's negative. And we can calculate these quite quickly. We want to take a couple of points that are easy to calculate. So let's look at this one here and this one here, for example. If we want to do rise over run on a coordinate grid like this, we can just look at the rise. Rise here would be up and over. So the rise is, counting the units or boxes, 1, 2, 3, 4, 5. That's right, 5. And the run is 1, 2, 3. So the slope is 5 over 3. The other way to do it, use when it gets more difficult than this and larger numbers, or the distance is greater and you don't want to count all the boxes, then you can use the formula for the slope y2 minus y1 over x2 minus x1, and we can plug in the values. So here's I always look at the point on the furthest to the left as our first point, point 1, call it P1 if you like, and this is point 2 on the right hand side. So what are the y, x and y coordinates for these points? We can plug them into the formula. Let's look at the y2. Well, that means point 2. What's the y coordinate? It's 10. It has a height of 10. You can always just write these beside it if you like. Let's look at the coordinates. So it's 6. X value is 6 and the y value is 10. So 6, 10. And let's look at the coordinates for this. We go over 3, so the x is 3, and up to 5, so 3, 5. Once you write the coordinates for the 2 points, or given the 2 coordinates, it's fairly easy to fill this in. So we want y2, which is 10. We want y1, which is 5. We want x2, which is 6. And we want x1, which is 3 here. And subtract 5 and subtract 3, so we get the answer of 5 over 3. Let's move down to the next section. Gives you the solution there if you want to read over it in your book or in the video here. Sorry about that. Now they did part C, and you can look at this calculation and how they get the negative value there. basically 5 minus 10 gives you a negative 5. 9 minus 0 gives you a positive 9, so it ends up being negative 5 or 9. Okay, so why don't you try one or two of these build your skills, and pause the video to do that. Now here's what I was talking about as far as rate of change goes. It's usually something that's changing, in this case distance, over an amount of time. So traveling in a car at a constant speed of 50 kilometers per hour for a length of time, you will have traveled 50 kilometers in 1 hour, or 100 kilometers in 2 hours, and so on. You can plot this on a graph. In other words, in 1 hour you've driven 50 kilometers, in 2 hours you've driven 100 kilometers, 3 hours you've driven 150, and so on. Notice that this means that the rate of change is 50 kilometers every hour. This other slope does a very similar thing, only this driver is obviously going faster. In 1 hour he's driven 75 kilometers, in 2 hours he's done 150. So if you calculate that slope, or that rate of change, it is 75 kilometers every hour per hour. Okay, and why don't you read over this? I don't want to take up too much time of the video when you can read this in your textbook, and or pause the video and read it here. Now remember, one other thing we did talk about in grade 10 was that one of these is the dependent and the other is the independent variable. We always put the independent on the x-axis and the dependent on the y-axis. Now you can ask yourself, does time driven depend on the distance traveled, or does the distance depend on the time? So the distance that you travel obviously depends on the time you've been driving for. So distance is dependent. So that distance would be the dependent variable, time would be the independent variable. So here's an example dealing with that. And it's talking about an electrician's wage. And he's been getting paid $12.25 an hour. And it asks various questions based on that. What is the dependent variable? And write an equation that shows the relationship between hours worked and the income. Graph the equation. What is the slope of the graph? What does it represent? How much will he earn in 5 hours? And also, if he earns this on a job, how many hours did he work? So let's go through the solution here. First question was, what's the dependent variable? Well, if you think about he's earning so much per hour, his wage, his dollar value will depend on the time worked. So the dependent variable is his earnings. Let E represent his income, H the hours he worked. We can graph this. So dependent is the earnings, goes on the y-axis always. The independent time typically is always on the x-axis. And we can see that if he works 1 hour, he gets paid $12.25. And if he works 5 hours, he gets paid 5 times that amount. You can do that on your calculator and plot another point up here if you like. So part B was to graph the equation. Oh, part A we've got to what does it say? What is it dependent? Write an equation that shows the relationship between hours worked and income earned. Well, simply the earnings. And remember, when you write an equation, we always usually write it, the equation of a straight line is y equaling the slope times x. Well, what's the slope here? Well, they're really telling us that the slope is $12.25 per hour. Remember the rise over the run? Well, the rise is $12.25 over the run of 1. $12.25 over 1 gives us the slope, this value here. Now x is the time or hours worked, so we can change this equation, and y, the y-axis is the dollars of the amount, his earnings. So we can write earnings will depend on m, the slope, in this case 1225, and whatever the x is. Now instead of x we're using hours, so we use h, the number of hours. So his earnings will be 1225 times the number of hours worked. And what was the second part of the question? The third part. What is a slope? What does it represent? So we can take two coordinates from the graph. We can take 0, 0, and we can take after 1 hour 1225. So we get these two coordinates here, and from that we can calculate the slope. It's pretty straightforward. We've done that already in the previous question. And use the equation to calculate his total earnings in 5 hours. So here was our equation here. The hours are now 5, so we multiply his hourly wage by 5, giving his earnings. So this is fairly intuitive and straightforward. Hopefully you would not have a problem figuring out how much you would earn in 5 hours. I use the equation for his total earnings to figure out the hour worked or hours worked. So in the last part, they tell you how much he earns. They tell you the value for E. They want to know how many hours H he has worked. Plug in the value he earned and set this equation up as so. And then if we want to find H, we've got to divide this by 1225. So divide both sides by 1225 and we get 15 hours worked. Okay, build your skills. I'd like you to try one of these before you come to class. Example 3. Okay, so what is it asking here? Reg timed himself jogging on a race course. I'd like to see that happen. Maybe. Okay, he passed the 300 meter point in 1.5 minutes after starting, and the 600 meter point after 2.8 minutes. Show this on a graph. So really we have 2 points. I imagine he starts at time 0 at 0 meters, so it makes sense to put this point right here. And then after 1.5 minutes he's reached the 300 meter mark. So 1.5 in time, and we go up, and at 300 meters we plot a point. After 2.8 minutes, which is about here, he has reached the 600 meter mark, so we put a point here with 600. So that's our graph. What was his average rate in meters per minute? Asking for part B, meters per minute for the race. What was his average rate? So that's really the slope, the average rate. So in other words, not this part of the slope, not this part of the slope, but from here to here. What's his average rate for this portion, meaning up to 600? Now if you look at this carefully, this slope here is not quite the same as this, but we want the slope from here to here. So we pick those 2 points. That'll give us the average of these two. Okay, so let's see what they have below for a solution. Okay, do they do that? They're not doing it the way I've suggested for some reason. They're taking the last part of, maybe I'm reading the question wrong. What was his average rate for this portion of the race? It's badly worded here. They really want this part of the slope. At least that's what they're calculating. So we take these 2 points. That's what they've taken. But if you wanted to calculate the average from beginning to the 600 meter mark, you would have to take this and this part here. So looking at their solution, they're using the formula for the slope, rise over run, or y2 minus y1 over x2 minus x1. And they plug in the values and they get 23.1. So 23.1, what are the units we use here? It's always the y units over the x units, or meters per minute. Yeah. Okay, so why don't you try one of these. Pause the video, and then in class we'll do the practice your new skills in the next class, and finish off any other build your skills that you haven't completed. Okay, we'll see you in class next day.